During the Carboniferous Period, around 320 million years ago, Earth's surface was dominated by vast, steaming swamps that covered huge portions of the land. These were not quiet, lifeless wetlands. They were overflowing with vegetation, constantly humid and thick with decaying plant matter. The atmosphere was very different from today, containing over 30% oxygen. That single factor changed the entire balance of life on the planet, allowing organisms to grow to sizes that would be impossible in the modern world. Towering primitive trees formed dense forests, their roots tangled into massive networks beneath the muddy ground. Ferns the size of modern buildings choked the landscape. Thick mists hovered just above the surface, created by constant evaporation and trapped heat. The ground was unstable, layered with wet leaves, fallen trunks, and slowly rotting plants that never fully broke down. Underneath, the soil was saturated with nutrients and gases released by decomposition. In the air above these swamps, the largest flying insects in Earth's history ruled the skies. Meganeura, an ancient relative of the dragonfly, moved between the towering plants with a wingspan that could reach over 2 feet. Its body was thick and armored, its eyes massive and curved, built to track movement across the dense environment. Fast, precise, and perfectly adapted to this high-oxygen atmosphere. It hunted smaller insects mid-flight, turning the sky into an active hunting ground. Closer to the ground, the vegetation was alive with movement. Primitive cockroaches, enormous beetle-like creatures, ancient spiders, and countless unknown arthropods crawled through the undergrowth. Every leaf, every stem, every patch of moss had something moving across it or beneath it. The forest floor wasn't silent for a single moment. It vibrated with life. Among the most striking inhabitants of this ecosystem was Arthropleura, the largest land invertebrate to ever exist. Stretching over 8 feet in length, its body was made of overlapping armored plates, each segment supported by dozens of legs moving in perfect rhythm. It slowly pushed through the thick plant matter, flattening anything fragile in its path. Though it likely fed on decaying plants and vegetation, its sheer size made it a dominating presence within the swamp environment. Wherever it moved, smaller creatures scattered, and the ground shifted under its weight. The extreme oxygen levels didn't just affect animal size. They also made the environment dangerously volatile. With so much oxygen in the air, vegetation burned more easily and more violently. Even a small natural spark, such as a lightning strike, could cause massive firestorms. Flames raced through dry sections of forest at incredible speed, climbing the towering plants and leaping from one area to another, turning entire regions into walls of fire in a very short time. At the same time, toxic gases were constantly being produced beneath the surface. As enormous amounts of plant matter decomposed in waterlogged soil, gases like methane and carbon dioxide built up in low-lying areas. These invisible pockets gathered between dense roots and heavy vegetation. Any creature passing through these spaces would be exposed to air that was difficult or impossible to breathe. Many would collapse into the wet ground, quickly becoming part of the same decaying system that produced the gas in the first place. This ecosystem was dominated by insects, arthropods, and plants operating on a scale never seen again in Earth's history. There were no large mammals, no birds, no familiar reptiles. The balance of life was entirely different, ruled by creatures that thrived in extreme humidity, extreme oxygen, and constant decay. The Carboniferous swamps were not peaceful prehistoric forests. They were intense, unstable environments full of massive insects, toxic air zones, and highly flammable vegetation. Everything was larger, more aggressive, and more extreme. It was a world shaped by excess oxygen, excess growth, excess danger. And this was only the outer layer of the environment. Deeper into these swamps, where sunlight struggled to reach and the air grew even heavier, conditions became more hostile and more alien. creating zones where even the largest creatures avoided entering. Deeper into the Carboniferous swamps, the environment became even more extreme. Sunlight struggled to break through the layered canopy of towering trees and massive fern-like plants, creating a dim, green-tinted world where shadows stretched endlessly across waterlogged ground. The air grew heavier, filled with moisture, spores, and the constant release of gases from decaying vegetation below. Little of the light that touched the upper leaves ever reached the surface, and this lack of airflow caused heat and humidity to collect, creating pockets where the atmosphere visibly shimmered. In these darker zones, insect life grew even denser. Since there were no birds to thin their numbers and few large vertebrate predators to control their populations, arthropods expanded into nearly every available role in the ecosystem. Some became hunters, others scavengers, and many specialized in breaking down plant matter that never fully decomposed. Ancient spiders stretched webs between thick stems and fallen trunks, their silk catching a constant stream of smaller insects drifting through the swamp air. Massive beetles with hardened shells pushed through layers of soggy plant growth, tearing into rotting material with powerful mandibles. The constant activity on the forest floor helped feed the cycle of decay. As one plant collapsed and another grew, entire layers of organic material were pressed downward into the mud. Over time, that material was buried deeper and deeper, trapped beneath the weight of new growth. This process, repeated for millions of years, is what would later form massive coal deposits. But in the moment, it simply meant the ground beneath the swamp was always shifting, always unstable, always thick with unseen movement. Arthropleura continued to roam through this environment, following paths formed by centuries of constant travel through the vegetation. Wherever these massive creatures moved, they flattened the land, creating narrow corridors through the dense growth. These pathways attracted other organisms. Smaller creatures followed, feeding on damaged plants and exposed material. Predatory insects and spiders waited at the edges, using the disrupted ground as a hunting zone. Even the slow movement of one massive creature could reshape entire sections of the ecosystem. Above, the skies remained controlled by Meganeura. With such an oxygen-rich atmosphere, their flight was powerful and efficient. They were able to remain in the air for long periods, gliding between tree trunks and open pockets of space, scanning the ground below for movement. Their presence alone influenced how other insects behaved, driving some deeper into the vegetation, while forcing others into brief bursts of activity before vanishing again into cover. But the most dangerous feature of the inner swamp wasn't any animal. It was the environment itself. In these deeper regions, gases produced from decomposition became more concentrated. Methane, carbon dioxide, and other unseen chemicals gathered in low areas, forming invisible layers close to the ground. These gases pooled between tangled roots and thick plant columns, creating sections of the swamp where oxygen was suddenly displaced. Any small creature moving through such areas would slow, weaken, and fall, quickly sinking into the soft ground below. At times, these gas pockets would ignite. A single spark from distant lightning or natural friction could trigger a sudden flash of flame across the swamp surface. Because of the high oxygen content in the air, the fire did not creep. It ran, it climbed, it leapt from tree to tree, racing along dry upper branches and igniting layers of dead plant matter in seconds. Entire sections of the swamp could be transformed into burning towers before collapsing into steaming, blackened remains. And when the fires burned out, the cycle began again. Ash enriched the soil. New growth erupted at an accelerated rate. Ferns, trees, and thick ground plants reclaimed the land. Insects returned in overwhelming numbers. The largest survivors laid eggs in the softened earth. Within a remarkably short time, the burned regions were once again dense, humid, and packed with life, often more intense than before. Destruction in this era did not end ecosystems. It reshaped and intensified them. This repeating cycle of growth, decay, and fire defined the Carboniferous world. It was a system running at maximum output, fueled by oxygen, saturated with moisture, and dominated by organisms that thrived in extreme conditions. The scale of plant and insect life reached heights never seen again, turning the planet's surface into a web of tangled vegetation and crawling forms. There was no open, quiet ground, no clear air, no simple balance. Everything was in excess. And as millions of years passed, this environment continued to expand and dominate the landscape. But that very excess would eventually carry the seed of its own ending. The same conditions that allowed such massive growth would begin to change, slowly at first, then more dramatically. Oxygen levels would drop, climate patterns would shift, the endless swamps would begin to recede. And when that happened, the reign of giant insects and armored land arthropods would come to an end, just as suddenly as it had begun. As the cycles of growth, decay, and fire continued, the Carboniferous world slowly began to change in ways that were almost impossible to notice at first. There was no sudden moment when the swamps stopped being swamps. No clear line drawn between one era and the next. The towering plants still rose toward the thick skies. The insects still filled the air. Arthropleura still moved through the tangled ground. Meganeura still ruled the space above the canopy. On the surface, the ecosystem still looked powerful, endless, unstoppable. But the conditions that made it possible were slowly fading. The first major shift was happening in the atmosphere itself. For millions of years, the enormous forests had been pumping oxygen into the air. Every massive tree, every layer of ferns, every mat of plant life growing in the swamp had added to that buildup. But as more and more plant matter became buried beneath the surface instead of breaking down, carbon was being locked away underground. That process created vast coal deposits, but it also began reducing the amount of oxygen being released into the atmosphere. It was subtle, slightly less oxygen in the air, barely noticeable at first. But in this world, oxygen was everything. It was the reason insects reached impossible sizes. It was the fuel that made fires burn hotter and faster. It was the invisible force that powered this entire ecosystem. And as that level slowly dropped, it began placing quiet limits on organisms that had evolved assuming abundance would last forever. Large insects, which depended on highly efficient oxygen absorption through their bodies, began facing stress. Their massive sizes required vast amounts of oxygen to support their tissues. Even a small decrease in atmospheric concentration made movement more difficult, growth less efficient, and survival more demanding. New generations emerged slightly smaller than the last, not by choice, but because the environment would no longer allow anything bigger to thrive. At the same time, the climate itself was shifting. The Carboniferous period had been warm and wet, perfect for massive swamp forests. But slowly, the planet began trending toward a drier, more seasonal climate. Rain patterns changed. Some regions began to experience longer dry periods. The endless, saturated wetlands that had once stretched across entire continents started to break apart into separate regions instead of one connected world of constant moisture. As wet zones shrank, the massive plants that defined the landscape began to die off in certain areas. Without constant water, some species could no longer survive. The dense, tangled forests that once trapped humidity and heat inside them started to thin in places. More sunlight reached the ground. The composition of plant life shifted from water-loving giants to species better adapted for drier conditions. This had a chain reaction through the entire ecosystem. When massive plants died, insects lost habitat. When insects declined, the hunting patterns of other arthropods changed. Arthropleura, which depended on vast amounts of vegetation and decaying organic matter, found fewer paths rich with food. The corridors it once created through thick plant layers became meaningless as forests opened up and changed into patchy, uneven terrain. Meganeura also began to feel the consequences. With fewer dense forests and less concentrated insect populations, its hunting grounds became more scattered. The wide, humid, oxygen-rich air it once flew through began to thin and change. Its massive wings, once an advantage, slowly became a disadvantage as energy became harder to maintain and prey became less predictable. And while the atmosphere was changing, the land itself was changing too. Continents were still moving. Tectonic plates were slowly pushing mountain ranges higher in some places and pulling land apart in others. These movements altered wind patterns and the flow of water, redirecting storms and shifting entire climate zones. Regions that had spent millions of years underwater began rising. Regions that had been forests dried into plains. The stable platform the Carboniferous swamp system depended on no longer existed. The once unbroken green expanse began to fracture. In some areas, swamps became shallow lakes and then dried up entirely. In other regions, they turned into muddy plains covered in low vegetation instead of towering forests. Animal life that had been tied to constant swamp conditions now found itself in a world that no longer suited it. And just like every great ecosystem before it, the Carboniferous world had reached its limit. But it didn't die all at once. It faded in patches. One massive swamp region would collapse while another still thrived somewhere else. Giant insects vanished from one area, but still dominated another. Arthropleura became rare, then extremely rare, then gone without any single moment marking the end of its existence. The world wasn't ending in a dramatic firestorm. It was quietly outgrowing the conditions that once made it possible. Over time, new kinds of animals began to appear in these changing landscapes. Early reptiles, better adapted to dry conditions, started spreading into areas that insects had once ruled. Their ability to lay eggs on land gave them a huge advantage over species tied to wet environments. They didn't require constant moisture to reproduce. They could move between regions more freely. Slowly, they started filling ecological roles that insects and amphibians once controlled. With each passing million years, the balance shifted further. The insect-dominated world gave way to one more controlled by vertebrates. The immense forests retreated. Oxygen levels continued to drop closer to what they are today. Firestorms became less extreme. Arthropods returned to more familiar, smaller forms. The atmosphere lost the intensity that had fueled the Age of Giants. The Carboniferous death swamp didn't disappear overnight. It was replaced, layer by layer, region by region, species by species. What had once been an alien jungle of armored monsters and massive wings slowly transformed into a world more recognizable, one preparing the stage for entirely different rulers. What remained after that transformation were the layers of compressed plant matter buried beneath the earth, coal seams that would last for hundreds of millions of years. The remains of a time when oxygen flooded the skies, insects ruled the land, and forests burned with a violence never again repeated at that scale. And beneath that coal, pressed deep into stone, are the silent records of a world so extreme it almost seems unreal today. Not a fantasy, not a story. Just a chapter of Earth's history where the rules were different, the air was different, and the dominant creatures were nothing like anything alive now. The death swamp did not lose in battle. It simply aged out of existence as the planet shifted into a new phase, one that would eventually give rise to reptiles, dinosaurs, mammals, and everything that followed. But for a very long time, this oxygen-powered nightmare was the true ruler of the land, and nothing has ever come close to replacing it. As the last great swamps continued to shrink, the character of the world kept shifting in subtle but unstoppable ways. The changes were not dramatic in a single moment. There were no sudden collapses, no instant silences, no clear ending to the era. Instead, the environment slowly lost the traits that once defined it. The air grew thinner as oxygen levels continued their gradual decline. The relentless humidity weakened. Rain no longer came in the same constant soaking cycles. Seasons began to form where there had once been only endless warmth and moisture. With every passing stretch of time, the swamp world became less of a closed, overflowing system and more of a broken network of isolated pockets. What had once been an unbroken maze of waterlogged forest turned into scattered wetlands surrounded by higher, drier ground. In places where the water level dropped, thick layers of plant material hardened into peat, then slowly into compressed rock. Areas that had once been submerged under shallow water turned into dark, spongy plains dotted with smaller trees and low vegetation. The organisms that thrived in the core zones of the Carboniferous now found themselves pushed into shrinking territory. Arthropleura became confined to smaller regions where moisture and dense plant matter still remained. The wide corridors it once carved through the undergrowth shortened, narrowed, and eventually ended at drier ground it could not cross. Its populations fragmented. Some survived longer in isolated regions where conditions lingered, while others disappeared without leaving clear traces. Meganeura faced a similar fate. The wide, oxygen-rich airspace it depended on no longer held the same structure. Forests thinned. Air currents became less predictable. The massive wings that once allowed it to glide effortlessly through thick, humid air became increasingly inefficient. Each flight required more energy than before. Prey became more scattered. The dense insect clouds that once fed it broke apart into smaller, inconsistent swarms. New life slowly filled the spaces they left behind. Early reptiles began to spread further across the land. Unlike amphibians, they were not bound to water to reproduce. They could lay eggs on dry soil, far away from swamp edges. Their skin resisted dehydration. They could travel greater distances and survive in environments that would have once been hostile to Carboniferous-era species. These early reptiles weren't massive or impressive yet, but their advantage didn't come from size. It came from independence. As the world dried, that independence became power. Plants evolved as well. The towering, water-loving giants of the swamp were replaced by species that could survive fluctuating conditions. Some developed stronger internal structures to stand without constant saturation. Others produced seeds that could remain dormant during dry periods, then sprout again when moisture returned. Forests still existed, but they were no longer built on excess. They were built on efficiency. The world began to stabilize into a different kind of balance, not the maximum output chaos of the Carboniferous, but a more controlled, more selective environment. Fewer organisms dominated in overwhelming numbers. Instead, life spread out into more defined roles. The intricate but extreme web of the death swamp slowly unraveled into separate, more specialized ecosystems. Fire also changed. Without such intense oxygen levels, flames no longer raced with the same unstoppable violence. Forest fires still occurred, but they burned more like those seen in later eras, destructive but limited. The great continent-spanning firestorms became part of the past. Smoke no longer blackened the skies the same way. The land had learned a new rhythm. As the swamp age faded, something important was being set in motion. The breakdown of the old system freed up niches, roles, and opportunities that had never existed before. Areas that were once dominated by insects became open to vertebrates. Food webs that had been simple and massive became more complex and layered. Evolution began exploring new forms, new strategies, new body plans. The Carboniferous world had not just ended, it had prepared the stage for what came next. The buried remains of its forests formed kilometer-thick coal seams beneath the surface. locking away enormous amounts of carbon. That single process helped stabilize the atmosphere in a way that made future ecosystems possible. The oxygen, once extreme, slowly settled closer to levels that allowed for more controlled, sustainable life. The planet moved from a state of excess to a state of balance. But even as it faded, the impact of the Carboniferous never truly disappeared. Every major forest that came after, every animal that walked on solid ground, every future ecosystem built its foundation on the transformation that happened during that time. The death swamp created the soil, quite literally, for the future world. It shaped atmospheric composition. It influenced the direction of evolution. It carved pathways for reptiles, for dinosaurs, for mammals, and for entire lineages that would appear millions of years later. Nothing that came after it was possible without it. And yet, despite its influence, the Carboniferous itself became distant, buried beneath layers of rock, forgotten by time. No towering fern forests, no giant dragonflies ruling the skies, no armored arthropods sliding through endless green. Only traces, fossils pressed into stone, coal buried deep underground, chemical signatures locked into ancient layers of earth. But the silence that replaced the death swamp shouldn't be mistaken for peace. It was simply the beginning of another transformation. A new world was forming, shaped not by insects and endless wetlands, but by creatures with backbones, jaws, lungs, and legs better suited for dry plains, open land, and changing climates. And in that emerging world, the scale of life would grow again, just in a very different way. The Carboniferous had been an age of overwhelming abundance. What followed would be an age of dominance by creatures far larger than any insect, walking across landscapes no longer drowned in swamp water, under a sky that finally looked closer to the one known today. But for those millions of years in the past, there truly was a time when the Earth belonged not to mammals, not to reptiles, not to towering animals, but to a humid, oxygen-flooded world ruled by forests, fire, and insects that should never have been that big. And nothing like it has ever existed again.